Preview screen, beginning. Welcome back. Hi. Yeah, I think everybody came back. That's a win, right? Yes. Is this too bright in here for this? Do I need to mess with this? Is it okay? Mess a little? Maybe?
Yeah.
Let me see. Let me go with present mode, which is different than all on. That's better? Okay, excellent. Yeah, only I can fall asleep up here in the dark. You guys are still lit up. So I had an interesting thing happen to me Tuesday when I was supposed to have my office hours in this room. Another class showed up instead. I was like, oh, didn't know about that. So I had to make a slight adjustment. I'm going to hang out outside this room on Tuesdays because there's all this open space and empty computers and plenty of space for us to all gather. So I'm just going to hang out outside this room on Tuesdays after my other class is done and inside the room on Thursdays. I double checked with the people in charge and I do have the room on Thursdays. So just a slight adjustment to that. I don't have your first quiz available yet, but that is the first thing I'm going to do after we get out of class today. So at some point between now and Monday at midnight, it should take like 10-15 minutes. That's the idea. It should just help you to be able to focus on what are the big picture things, that kind of stuff. Homework 0, if I didn't mention this last time, we're going to do it in class. It's going to take 30 seconds, okay? It's literally just about the syllabus, a couple of questions. It's designed to make sure that you all know how to use the system. I've been waiting to see if there's going to be anyone who adds or drops before I get that ready, but that will be ready for us to go over on Tuesday. And at the same time, I will get your first homework up. My goal is to give you at least a week to complete these homeworks. Given that the first one might be a day or two shy of that, it's not going to be that long or troublesome. So we should have all the skills to be able to do that this week and heading into next week. So that's enough housekeeping.
Thank you.
I have a quick question.
Sure.
I think you've said this, but I just want to double check. So where are we supposed to find these directions for what to do for FA1?
Inside Icon.
It's in Icon.
Yep, it'll be inside Icon. So there's it's called quizzes or assignments or something. I'll check to see exactly what it's called, and that's where they'll be. Yep. All right. And if I don't meet my goal of getting through all of the material that I want to by the time this rolls around, I will push it back. So I will never make it due sooner, but I may make it due later if we don't get through everything. Yeah.
I did click the example to introduction to SASS data.
Yes.
And it opens a file.
It opens up a zip file,
Yeah.
a compressed file.
What exactly do you do? I'm trying to print them out.
You don't need to print anything. Inside this zip folder, so this is what's known as a compressed folder. It makes it so that I can stick a whole bunch of files into one folder and you only have to download one thing instead of 8 things. But what you have to do once you download it is save it somewhere where you know what it is. All Windows, Mac have ways of extracting a file. This one is if you just go to where the folder is, and let me see here. It downloaded here. So in Windows, for instance, there's an option for extract all. My computer upstairs came with something called WinRAR as another program that does this. Mac people, how do you extract?
Yeah, just
Double click, okay. So the extract thing is to make sure that the files are editable. Otherwise, if you navigate to this folder, all the files are read-only. So what is going to be in here, I'll show you once we get the folder open, are several different files. So I'm borrowing a data set that one of your textbooks use. It's the General Social Survey. So I have the data set in a couple of different formats so that I can show you how to import data of various kinds into SAS and SPSS. I also have syntax that we're going to go over in class, and then I have the output saved as to what the syntax creates. So that way, if you get lost or otherwise something goes wrong, you'll know what it should have looked like. So does that help? Okay. Yeah, whenever we have examples that include data, code, and output, I will put them inside a compressed folder. That way you don't have to download all the separate pieces. But you shouldn't need to print any of it, and it's actually easier probably if you don't, because these syntax files are things we're going to edit as we go. All right, other questions? Okay, so last time We looked at some new words, right? Ding! Correct. What do you remember from last time? I accept words, letters, phrases, and gestures.
Covariate.
Covariate. That's a good one. What's a covariate?
Things that other people care about.
Correct. But you have to pretend to care or they won't publish your work. Yes, so is a covariate a predictor or an outcome? Predictor. What's the difference?
Predictors explain things, and outcomes are to be explained.
Yes, predictors are the explainers. Outcomes are the things to be explained. It depends entirely on how your question is worded, which is which. So if I say something like, is education related to income? That doesn't tell me which is which. That will be an example of a bivariate association. That's the next topic, just how two variables are related to each other. But if I say, is income higher in people who are more educated? That's a directional statement. Which is which? Which is the predictor in that sentence? Mm-hmm. And the outcome then is money. Yes. Exactly. What else? Say it again.
Independent and dependent variables.
Mm-hmm. So independent variable, or IV for short, goes in which column? Predictor or outcome?
Independent.
Mhm.
Predictor.
Predictor. What's the analog to that? If I don't have an independent variable, I may have a dependent variable. That goes in the outcome column. That's language that people who are conducting experiments use. IV and DV. What else? Other words?
Descriptive and inferential.
Yeah, what's the difference?
One's just talking about what it looks like, and the other one you're trying to make a guess or a prediction or an inference.
Yeah. Yes, way to use the word in the definition. Yes, but yeah, exactly. In reality, it's not quite as cut and dry. So the example that I'm going to show you today, for instance, is testing the idea that the mean from your sample is somehow different than the mean you would expect. Right? The mean itself is descriptive, but if I want to compare it to some other value, that becomes inferential. So it's about the aim. Good. How about, what does univariate mean? One variable. How about bivariate? Hey, we're doing excellent today. Let's see, what else? I know, independent and dependent samples. That was one we talked about briefly. Ideas? Examples? Definitions? Samples this time. So in terms of how we characterize the people that are in our study and how we expect them to be related to each other or not. That's the defining feature. So which one is it if people are related to each other for some reason? Dependent, yes. So there's independent, which is what it sounds like, and dependent. Or sometimes it's phrased non-independent, which is redundant, but it works. So in this class, the models we are focusing on for most of the time are assuming that you have an independent sample. That's not to say that we can't address dependent samples, just not in this class. You have to stick around for the later class if you want to do that. But the independent is a good place to start. Okay, I think that's all the high points. Any questions before we jump back in? No? All right, let's do it then. So we left off here, slide 18 in lecture 1, and we're ready to talk about kinds of variables. Oh, that's a good one. What's a variable? I think I heard you say this after class, that you had never had a definition of variable before, or it was useful. Am I remembering this correctly?
I probably did say that.
What's a variable?
I don't remember what it was so great about the definition, but the thing to be looked at.
I'll take that, not where I was going, but I'll take
Characteristic.
it. What is it with respect to the sample?
Something that varies.
Something that is different across the people, something that varies. So varying variable sort of That's cheating in the definition, but it's the idea that it's something that isn't the same for everybody. Now, that could be because you chose it that way or because that's what happened. So for instance, if the example I gave was sampling graduate students from one program or multiple programs, if I make the decision to sample from only one program is not a variable, it's a constant. And I may be doing that to narrow the field of inference that I'm trying to make. Like, I only want to know about people in this program, therefore those are the only people who are going in my sample. Or it could be that it just worked out that way. So I had a data set recently I was looking at where they were coding particular types of behaviors that teachers engaged in, and it turned out that one type of behavior every teacher in the sample engaged in. So even though it was being collected as if it could vary between people, it didn't. And if it doesn't, it can't go in a model. It can't be an explainer, and it can't be a thing to be explained. So we want variables, not constants. Kinds of variables. Lots and lots and lots and lots. So this is another whole new set of vocabulary that you get to use to characterize different kinds of variables, and this leads directly into how we think about them as predictors or outcomes. So the first kind here, as an aside here, your textbook lists things about levels of measurement. This is related to that, but it's a little more detailed in some places, and other things I sort of gloss over. So just know this is my version of it. This is the way that I approach it when I'm listening to people talk about their research, and I'm sort of going through the catalog in my head of all the things I need to worry about. I need to know what kind of variable each thing that they're interested in is. So the first main category here, categorical. That's one kind. That is the type of variable where even if you've indicated a label for it in a data set using a number, for instance, it's not a numeric variable. So binary. This is a synonym is dichotomous. It's a variable where there's only two possibilities. So dead or alive, as an example. Pregnant or not, right? That's sort of an old joke. You can't be a little bit pregnant. In older research, another example might be something like male versus female. Nowadays, not cool to talk about it that way, right? So binary variables are actually pretty rare. They show up more out of convenience because you didn't give people enough choices. But this is sort of, if you have constant as one end of the spectrum, this is one step away from constant. One of two values, that's all you get. Another kind of categorical variable is what's known as nominal. And these are three or more choices, but they're not ordered in any way. So if I asked you, what is your favorite type of pet? I'm going to go cats. Any other cat people? A few. Dogs? Boo. I'm sorry, that is incorrect. Goldfish? Anyone? Rabbits? Ferrets? Mini cats? They're squishy and, Anywho, these are three or more categories, but they're not related to each other in any sort of order. Contrast that with ordinal. That's where we have three or more categories, but they have an order. And this shows up a lot in questionnaires where you're asked to show how much you agree with the statement, for instance. So if I say 1 is strongly disagree, 2 is disagree, 3 is neutral, actually this example I did 3 is agree, 4 is strongly agree. Those are numbers assigned to labels. They're not really numbers though. But given what the labels mean, we could all agree that there's an ordering here that makes sense to maintain when you think about the variable. I put as a point of comparison here, if I assigned these labels this set of numbers instead, 1, 20, 300, and 4,000 doesn't change anything. The distance between the numbers doesn't mean anything. The ordering of the numbers means something. So all three of these fall under the heading of categorical. Here are some synonyms. They are discrete. They are a qualitative variable to some people, not to be confused with qualitative analysis. That's a whole separate thing that I know nothing about. For real, I can't help you there, right? So all of you who are like mixed methods, I'm like, good for you. This is not my party. We all specialize. Grouping variable, factor variable. People who know R, anybody in here? Yeah, a little bit? Like a factor variable in R? That's what I'm talking about, this one. In SAS, it's called a class variable, which stands for classification. In Stata, it's I-dot, if any of you are familiar with that program. So there are ways in software to tell it what kind of variable you have, and that turns out to be a really useful thing. Okay, so categories. The other main sort of umbrella heading, if it's not categorical, I'm calling it quantitative. This is where the numbers mean something. They come in many shapes and sizes, but the key thing here is that these are interval measurement. So if I have a variable for something like number of cigarettes smoked a day, the distance between 10 cigarettes and 11 cigarettes is the same distance as 11 and 12. The units mean something in terms of the distances. This page has specific types of quantitative variables that have unique features, and they have to do with boundaries. So in the first case, something called binomial. Did any of you have like intro stat a million years ago, and you talked about coin flips and stuff like that? That's the binomial distribution, right? And she's like, yeah, nah. Yeah, we're not talking about coin flips in here. You know why? Because no one has a research question about a coin flip. Except in the stats books where they're searching for an easy example that no one's going to argue with. By the way, heads versus tails, what kind of variable is that?
Binary.
Yeah, correct. Give me a synonym for binary. Starts with a D.
Discrete.
Discrete. Another one that starts with a D. True, but not where I was going. Dichotomous, yeah. So that's an example of a truly binary, right? You can't have a coin like land, on neither side. But binomial, if you have multiple coin flips, that's where that example goes. Like if you flip a coin 10 times, what is the probability that you would get 5 and 5, 6 and 4, blah, 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 blah. That's the binomial distribution. The reason that I bring this up is because this shows up in things like accuracy, things like rates of behavior out of some amount total. So if you have accuracy on a test, what is the worst you can do? 0. Yeah. Can you have negative accuracy? Only with certain scoring systems, right? Where you lose points for getting things wrong. And if you are the most awesome student ever, what's the best you can do? 100, right. So it has natural boundaries. In the coin flip analog, you could have like 0 heads and 10 tails, or vice versa, right? So it's quantitative. Distances between numbers mean something, but we have to pay attention to the fact that it can't go past certain points. It's bounded on both ends. Bounded on one end is a type of variable called a count. So the example I gave, number of cigarettes smoked a day, starts at 0, right? Hopefully that's most of us, right? Since, smoking causes cancer. Smoking is highly associated with cancer. But it goes to positive infinity, right? So it's bounded on one end. And the reason that we want to care about that is in thinking about how this variable relates to other variables in a model, we have to be careful that we don't predict something like negative cigarettes. The model has to understand that it has to shut off at 0 in terms of the lowest possible value. There are special types of count variables that you may hear about. By the way, how to predict all of these things as outcomes is coming next semester. We'll just have them as predictors for now. 0 truncated, or truncated, depending on how you want to say it, is when you have a count variable with no zeros. So this can happen in certain cases where the phenomenon that you're studying sort of implies that you have data. So let me give you a more concrete example. If I am looking at days of hospitalization related to number of infections or something like that, and my data come from a hospital database, what is the minimum number of days you have to be in the hospital to get into the database? We got to be there, right? 1. So there will be no zeros. And so in that case, we have to tell the model, okay, 1 is the lowest possible, not 0. There's also something called a zero inflated count, which I will have pictures of in just a little bit, when there's more zeros than what would be expected. Okay, so quantitative variables, numbers that have boundaries. That's the theme here. The other kind of quantitative variable is continuous, and that means unbounded. So it means two things: that it can take non-integer values, so you can have decimals in between numbers. It's not just like 1 cigarette, 2 cigarette, 3 cigarette. So an example of that would be something like response time. You can measure fractions of a second to whatever level of precision your software is capable of recording. And it would be unbounded is the other part of it. It could go on forever and ever from negative to positive infinity. There are basically no variables like this, like ever, in real data. But this concept shows up because that's what models assume for convenience a lot of the time. So the models that we're looking at this semester, as I gave you the name last time, general linear models, they say that the outcomes in the model must all be plausibly this way. That's the assumption that we're working with. So even though it's not very realistic, it's really convenient. And it makes the math a lot simpler to be able to ignore potential boundaries. So I want to introduce a category that I've made up off the top of my head for sort of how this plays out in real data. And instead of calling it continuous, I'm calling it continue-ish. So ordinal treated as interval. You will see this a lot. So much that it's actually a thing. So Terry's nodding, right? You've seen this before? Ordinal treated as interval? Who says that in your world?
Psychology.
Yep. Guilty. So yeah, no one would argue with this first one. So if I have that item before, strongly agree, agree, or disagree, strongly disagree, disagree, agree, strongly agree. That's ordinal, right? If I take 10 of those and add them together, ta-da! It's interval. Because I have enough of them. I'm going to say that my sum score, which ranges from 10 to 40, is continue-ish. It's enough. That happens all the time. In reality, it has two bounds. Whether or not those bounds are observed in your data depends on the distribution, whether it's sort of everybody's kind of in the middle, or whether it's something to where most people are low or most people are high. So we'll learn the words for that in just a second. Same thing if you took the average across items, which is better whenever you have missing items. Then the range is 1 to 4, but it's the same problem. So people in practice would have no problem calling these continuous interval variables, even though they're not really. They're continuous enough-ish. Here are some more examples that you may see, something like heart rate or response time. Those really are continuous from the perspective that they have non-integer values, but they're probably bounded. Like, what is the fastest response time you can have? At like something right above 0, right? You can't be negative and it can't be 0. So there is a boundary in practice. Whether you see that in the data depends on what the response time is for. So as an example, I'll tell you about my new favorite show, Beat Shazam. Do you know this show?
Oh.
She's like, I'm
made
listening.
it to almost the final round to
What?
be on it. Yeah.
What?
Yeah.
How did you do that? Because I need to do this.
Yeah. Anyway, yeah. But I was almost the final round to make it on.
Where
So
did
I
you
know the
try
show,
out?
But I have 2 summers ago.
2 summers ago. Oh, see, I just found out about this show this past summer. Beat Shazam. It's Monday nights, or it wasn't on this week, at 7 o'clock on Fox. And it's Name That Tune. So any old people here, you know what Name That Tune is, right? Well, this is Name That Tune for the millennials. So there's an app on your phone. I'll pull it up. Sorry, I have to digress here up on topic. Shazam. All right, so
I didn't realize it was the same.
yeah, so when you play music and you want to know what it's called, you hit the app and it listens. And within 5 seconds, it can identify basically any song on the planet. So the people are competing against each other to name that tune, and then for the final round, they beat the app. That's what happens. So on that show, like the fastest response time I've ever seen was a second, right? And actually, if you play along on the app while the show is on, it times you against the people. Yeah, it's fun. It's very fun. But so anyway, the distribution of response time, that's where I was going. I swear I had a point. The distribution of response time in that case doesn't get down to 0. It's possible that it's normally distributed with like a mean or continuous, haven't gotten there yet, like 2 or so is sort of the middle point. And so that might be an example, like Shazam response time might fulfill this continuous type of quantitative distribution, something like that. Also, for those of you who are going into measurement, like theory and technique measurement stuff, segue here, you're going to get things called latent trait estimates out of those sorts of courses. Those are supposed to be continuous and unbounded, but in practice, if your scale has a ceiling or floor effect, those are going to have a pile at one end too. So even though it's not plausible that we have something that's truly continuous and unbounded, we pretend we do a lot of the time. I know, it gets somewhat dissatisfying. It is. But I'm keeping it real. So I showed these slides to my husband, and he made me throw this one in because he said that some people have ratio scales. And I'm like, really? Because I've never seen one. But I guess economists who study money, that's a ratio scale. The difference is that a 0 really means something. And so you can talk about, say, with a ruler, like 6 inches is half as long as 12 inches. And you can talk about ratios of things in that way. Most psychological variables or things that you would collect in social sciences don't fall under this category. So if I have an IQ test, for instance, I can't say that a score of 50 is half as smart as a score of 100 in the same way that I can say 6 inches is half as long as 12 inches. So, there. I presented ratio. I did my due diligence. So, how are we doing so far? All right. So let's do some practice with types of variables, predictors, and outcomes, shall we? Let me see here. So this is the same examples that we had before. So to what extent does positive feedback improve performance, speed, and accuracy more than neutral feedback? And before we said that feedback was a predictor. Now what kind of predictor? Feedback is discrete, I'll take that one, comma, more words. Starts with a B. Binary. Starts with a D. Dichotomous, yeah, any of those will work. Discrete is a more general word than this, so I'd probably stick with these two as the more specific instantiations, but binary is a special case of a discrete variable, so that works. We have 2 outcomes. Speed. What do you think that one is? So I'm going to start you off by saying they're both quantitative, but more specifically, what do you get? What would you guess?
0 truncated?
Only if, good guess, but only if speed is rounded to the nearest integer. Because that is a distribution that doesn't have middle values. But yeah. This one I'd say you could call it continuous, right? It might be bounded at 0, but we'll say 0, bound, but continuous, continue-ish. I'll give you continuous on that one. How about accuracy? Here, let me set this here. Both quantitative, both quant. Speed is 0 bounded but continuous. What about accuracy?
It's bounded, right, depending on how you measure it. Either you're accurate or you're not accurate at all. 0 or 100% accuracy.
Or there could be rates of accuracy, right? If you go anywhere between 0 and 100, that would probably be better from a measurement standpoint to differentiate people. But this one is a special case of, also starts with B, when you've got 2 bounds. That'll be a binomial. Because you can always phrase accuracy as number correct, and that fits the binomial distribution directly. Let's see, next one. Faster academic growth related to more frequent reading to children. So reading is the predictor. information to make this distinction?
No.
Nope. What does more frequent mean? It could be a score on an item, like how frequently do you read to your child? Never, sometimes, usually. It could be out of how many nights of the week do you read to your child? Bleh. So, I'm putting that down. I don't know. You'd have to find out more information to be able to figure out what kind of variable that is. Academic growth. So time, as a predictor, is going to be quantitative. That was the other one. We don't know anything else about that without knowing how many occasions there are, how spaced they are, any of that kind of stuff. Academic something. Could be anything. No idea. And actually, sorry, that one goes down here. So, how effective is teacher training for creating higher rates of positive feedback? Rates, that's the key word here. Rates of positive feedback, a rate.
Are you reading?
Hmm?
I'm just talking about
Oh,
myself.
okay. So rate is related also to percent. There's your clue. That's another type of binomial, yeah. Because in order to calculate a rate, you have to have number of something happenings over some sort of total possible, right? And effectiveness so this may seem sort of silly given that I wrote these questions to be vague, but what I'm trying to illustrate here is that you can have questions about variables. These are all constructs. We don't know enough, we don't have enough information to come up with an analysis plan based on this. So that's one of the first things that when you're thinking about how to develop questions, think about how the things are measured and how you can word them more specifically so that you can get a more direct set of answers, more direct line to those set of answers. So at some point in whatever document these questions were in, they'd have to define what they mean by effectiveness of teacher training, because that could be anything. All right. Okay. The last part here is pretty much orthogonal to the rest of this, but I thought it was related because we're talking about variables. And given that we're not doing hand calculations and we're not doing stuff in Excel, you're going to be working with software. Software implies a database. So these are the things that drive me nuts when I work with other people's data. These are the mistakes that people sometimes make that I want to save you from if you are new to the concept of working with databases. So databases, is that a word that you guys know? Yeah? You don't use them?
I don't know how to use that.
That's okay.
Word.
So entering data, that's one thing that people have to do. I will point out that you can use whatever program you want. I like entering data in Excel. Even if I'm going to put it in something way fancier to analyze it, I like the freeze panes, I like the splits, I like all of that. So don't let anyone tell you you have to enter it directly into SPSS or something like that. All programs have the capability of importing all kinds of data. In terms of naming your variables, all programs are also smart enough to realize that if you have an Excel database or a spreadsheet and you put words in the first row, you can tell it, use those words as the names of my variables. That way you don't have to type them again. But in so doing, you have to obey the rules of what variable names can be in programs. And this is where it goes awry because you have to think like the computer, not like a person. So for instance, you can't use spaces. People get around that sometimes by doing underscores where the spaces would be. And in fact, if you have spaces, most programs will convert them to underscores. So to make it easier on yourself, just use those in the first place. I'm not a huge fan of underscores. I tend to do title case to save them. Do you know what I mean by that? So like, do I have any markers? Yeah, I do. So if I have a variable that's something like, number of cigarettes I might say num, and some people would say like sig or something like that with an underscore to delineate the two words. What I tend to do to save myself some typing would be to do something like this.
Oh,
That's called title case. So that way the words sort of jump out at each other, what they mean. But in practice, you don't get to use any special characters other than underscore. Use only as many characters as necessary is my advice. It used to be that all programs made you stick to 8 characters or less. That is only true in some programs now. They let you use lots and lots of characters, but then every time you type that variable, you have to type all those characters. Don't do that to yourself, because you have to spell it correctly each time for the computer to know what you meant. So instead of writing really long names, you can use labels. All programs have the capacity to take a column of names and attach it a longer label. So that's where if I have something like numsig, the label that would go with it would be something written out where it's like number of cigarettes in, you could put the whole question there so that you know exactly what it is. And that's there for your reference in the data file, but you don't have to keep typing all of that every single time. All variable names must start with letters, not numbers. You can start with an underscore. I didn't make these rules up. I'm just the messenger here. If you have a series of related variables, it's helpful to use a common stem. So if I have a stress scale and I have multiple items, it is way easier on you to name them with the item number than what is in the item words. Save the words for the labels, because when you need to abbreviate a series of variables, for instance, in the programs you can say stress 1 dash stress 50, it understands that you mean every single number between them. You can't use that shorthand if it's like stress 1 is family, stress 2 is work. There's no way to abbreviate words like that. Let's see. Other stuff? Categorical variables. So I told you that those mean numbers that are not numbers. They're just labels, right? So for that reason, a lot of people, when they have categorical variables, like, dead or alive, would enter the words directly. That's what's known as a string variable. It's a text variable. There's nothing wrong with that if you are the most detail-oriented person in the history of the world, or if all the people you work with are too. Otherwise, it causes problems, because text variables are case and space sensitive. So if it reads control group with lowercase and 1 space between them and no spaces at the end, it does not know that that is to be the same thing as control group with a space here and a space here and capitals. To the human eye, it looks the same. To the computer, it is not okay. And do you know how many ways there are to misspell even the simplest word? Don't do that to yourself. Put 0, right, for control group, and 1 for some other group, and 2 for some other group. And then in the labels, so just like you can attach labels to variables, you can attach labels to values. Then you can indicate that 0 means control group. And all programs allow you to print those labels with the numbers, so you don't have to remember what's a 0 and what's a 1. When you're making those labels, though, I strongly advise you to insert the number, even though it seems redundant. I found this out the hard way actually not too very long ago. So when you just have the labels, like if I didn't have the 0 here inside the quotes and the 1 and I had control and alternative, some programs, including the ones that we're going to use, would resort this alphabetically. So alternative group would be the first thing that shows up and then control group, even though you're thinking it's 0, 1 and it's backwards. So it reorders your list of possible categories, which I find I just can't handle. I can't take that. So I stick the numbers in there and then it puts them in the same order. If you have a situation where you have, say, a notes field, so if somebody didn't have a value and you wanted to write like why that happened, don't put the words in the same column as the values, because it will make the entire thing a string variable. Instead, get a new column. And I would argue the same thing for missing data. This might just be my humble opinion, but it causes more problems than it saves to put missing value codes in. Because if you forget to delineate, say, that minus 99 means the thing is missing, it treats it as a real number. Do you know why people put minus 99? Because it's unlikely to show up in practice. But it could. Some people put 99 instead of minus 99, and that number is more likely to show up for certain kinds of things. So just leave it blank. Leave it blank. That's what it is anyway, right? It's not there. If you need to keep track of reasons why it's not there, that's a new column. That is a new categorical variable that says present, missing for this reason, or missing for that reason. Okay. And then last but not least here, this is time saving for people who work with dependent data. So do you know what kind of data you work with, by the way? Is that a question? Because hopefully you have like some reason to be here besides someone's making you, right? Some of you do, some of you don't, right? Who here has worked with data before? Okay, everybody has. You got a reason then?
Qualitative data. Yeah, but
Okay, well, no, but you collect do you collect like demographic information about people?
absolutely, yes, we do.
Okay, so tell me like a typical qualitative study that you would have data from.
Teachers.
Teachers. Are they organized in some way, like within different schools or classrooms or anything like that? Okay, so do you go to multiple schools? Okay, so multiple schools, multiple teachers. A dependent sample, right? Would you collect school level information? Like the number of kids that they enroll and all that stuff, and teacher level information?
Like education
Mm-hmm.
and years in the
SES
field,
and
yes.
Yes, okay.
Sociodemographics.
So that then warrants two different kinds of data sets, right? A school level data set and a teacher level data set. If you were to try to start with a school level data set, or excuse me, a teacher level data set, and then you got to a variable that was about the school. If it was teacher level, you'd have to enter the same value for the school all the way down, all the teachers, right? That is unnecessary. If you have a school level data set and a teacher level data set, you can merge school into teacher and it does that for you. That is it.
Well, I've run into very similar problems. I'm like, this chart is stupid. But yeah, I get it. I didn't know you could merge them together, but
Yeah, and
you're and I are going to learn a lot.
Well, and you can do the opposite. So if you start with a data set that has, it's teacher 1, teacher 2, teacher 3, something like that, and you didn't have the school information separate, but you wanted to get it, like you could have to aggregate like the values across these teachers, the values across these teachers, the values across these teachers. I once spent 6 weeks doing that manually because I didn't know that was one line of code in graduate school. 6 weeks, I'm not kidding. And by the same token, that I've heard other people like spend like their whole summer like doing this in Excel because they didn't know that programs would do this kind of thing for you. It's a rite of passage to make these mistakes, but it's my job to keep you guys from making them anymore. So yeah, this data set thing, when you have multiple types of sampling, the most efficient thing you can do is a separate data set for each type. Because you can always merge them and combine them in different ways, but you don't have to do redundant data entry otherwise. So Alfonso, did you have any of these problems?
Yes.
Yes. What did you have to do?
So we had different data sets. We had one for diagnostic survey questions. We had another one for demographics and some others. And so we had to merge them together based on the person ID.
Mm-hmm.
And so I did that in SPSS and it took me 3 days to figure it out.
To figure it out, yeah.
But then I found out you can do it in R using the merge function, and it does it by ID automatically. And so yeah, I've had to do that before.
Yep, it's always a learning curve, but that brings up an important point. This falls apart completely if you don't have an ID. So sometimes people don't put IDs in, like on purpose, but then every time you resort the database, it changes who's where. Each person has to have a unique number in order to merge things across sources like that. So I've seen people who didn't, and it was like, well, why don't you have an ID number? So, and the other thing is that when you have an ID, you got to name the variable the exact same way across all these places, right? because person ID, subject ID, participant ID all sound like ID to you, not the computer. It's like, how am I supposed to merge it? These are two different things. It doesn't know. So yeah. So these are all instances in which you would have separate databases for separate levels of analysis. Don't be afraid to do that. It's super easy to merge them together once you know how. SPSS in theory has the merge commands too, but if you don't have the documentation to go with it, it can be tricky to figure out which one it is. What's a table? What's a file?
I had to do something like aligning them
Mm-hmm.
to be in the same column.
To be missing?
No, in the same column. Because in the different data sets, they were in different columns.
Oh, that's a whole separate thing.
And so then I had to put them all in the same column and then merge.
Do any of you work with programs that spit out individual text files? Things like Noldus, I know, is like for a qualitative type thing. There's other ones. Nobody does that? Okay, well, if you're ever in a situation where you have like 1 million files and you need to somehow get them into one, let me know, because there are really easy routines that I can help you find or make for you to do that. Don't hand enter things, ever. That's a recipe for disaster. So if you're in a situation where you're going to have to do something and you don't know how to do it, so you're just going to do it yourself by hand, stop and send me an email.
You ready for this?
Yes, just trust me on this. So I am happy to help let you learn from my mistakes. So wrapping all of this up then, here's the goal for the semester. We're learning language. So far it's just words, but it's also going to be notation, symbols that go with the words in the context of the models. Applying these to both descriptive and inferential statistics, independent samples predominantly, and I already made a pitch for why this class is not enough if you want to be able to do quantitative data analysis. We talked about variables here just recently, categorical versus quantitative. That's really the main distinction to keep in mind. That's the big one. Quantitative is numbers are numbers, categorical is numbers are labels. They're treated very, very differently. I sometimes slip and I say categorical versus continuous. I'm trying to change that, but I'm just going to warn you. Quantitative is really what I mean. It's more like continue-ish numbers. The idea that we can treat them as numbers. All right, we're in pretty good shape here. That's that. We can dive into lecture 2. How would that be? I have lots of fun pictures for you in lecture 2. My husband was afraid I was going to scare you. So I'm just going to tell you, I'm not showing these to scare you. I just want to show you pictures of what it looks like when these variables, what these sort of variables would look like, right? You've learned the names, and now you can learn sort of the pictures that go with the names. That was my